So the next topic we are having that is about the wave. We will discuss the wave in very detail. Okay. So what is wave? Wave is basically the disturbance of medium, that is wave is basically produce, or you can say that wave basically transfer of energy from one point to another without medium without medium. For example, a person is having a rope here, okay, and here one person is there, okay. A person is having a string in here, okay. If a person is like moving it with the jerk, so the wave is basically produced. So that wave is basically produced by the medium, by the string. So that is basically what, that is the wave. For example, there is a lake and I'm throwing the stone into that lake, so you will see that the at the side of that the wave are basically produced, okay. So these are what, these are the wave, okay, with the disturbance of the medium. Without disturbance of medium, that I'll be telling you how. So wave basically always carry energy. All waves, electromagnetic, all the waves carry the energy. So we are having the two types of wave. First one is electromagnetic wave. Second one, we are having the mechanical wave. So if we talk about electromagnetic wave, they are basically having the no medium. And if we talk about the mechanical wave, they are having the medium. So this definition, disturbance of medium, this definition is basically used for the mechanical wave with the medium, and this definition is without the medium. So this definition is used for the electromagnetic wave. Understand? Okay. So for example, you can take the example without that, produced without the medium, that is alpha rays, x-rays, alpha rays, gamma rays, UV rays, all the UV rays we are having, all the electromagnetic rays we are having. And if we talk about the mechanical, we are having the example that is the sound wave which produced by the medium. And this electromagnetic wave only follow the transverse path, okay. And if we talk about the mechanical, so they basically follow the longitudinal as well as the transfer. So which means transfer is basically both common in both. But if you talk about longitudinal, so longitudinal is only in the mechanical waves, okay. So next I want to tell you guys something about the wave, okay. I want to tell you guys some points about waves, like what's the difference between transfer and the longitudinal. So if we talk about the transverse wave, so this basically travel with the crust and the trough. What is crust and trough? For example, I'm having the wave. This upper part, this one part we are calling it the crust, and this one part we are calling as a trough. Okay, if we talk about longitudinal, so longitudinal basically move with the travel and the compression and the rarefaction, as you guys all know. Now we are having the little bit terms about the wave. One term we are having, that is the amplitude. What is amplitude in actually? Okay, that we'll be discussing today. Okay, what's the difference between amplitude? Amplitude is basically denoted by the XO, HO, and AO. What is amplitude? The maximum height of the wave is called the amplitude. This is the maximum. Amplitude can be here, but that will be not maximum, that will be minimum. But if you talk about this one, so this is the amplitude, but the maximum, okay. Or you can say at the extreme position, okay. So different wave is having the different amplitude, okay. And this amplitude is basically measured by the different instrument. Every Wave is having the different instrument for measuring the amplitude. Okay, if we talk about the sound wave, so sound wave is having the instrument which is sound. What is sound? Sound is the instrument through which you will like find the amplitude of the sound wave. If we talk about the sound, so sound is one sound is basically equal to the 28 decibel. What is decibel? Decibel is basically the unit of the sound wave. Okay, next term we are having that is the wavelength. What is wavelength? This is the wave. This is called the wavelength. The distance between the crust and the trough, we are calling that as a wavelength. And if we talk about the SI unit, so that is the meter. Okay, if we talk about the crust basically tell the positive part, upward part, positive part, and trough basically tell about the negative path. Okay, the third term we are having the about the wave, that is we are having that is the correct. These are all the characteristics I'm telling you guys. Okay, time period. What is time period? Time period is basically denoted by the f, and if it t, and the formula we are having that is the 1 upon f. Okay, one we are having the cycle. The definition we are having the time required to complete the one cycle, that is called the time period. If the time is required like two cycles are there, if the one time like the requirement of one cycle is basically for example 2 seconds, so we will write 2 upon f. F is what? F is the frequency. Okay, so the one cycle, which means this is the, for example, this is the wave, so this is called the one cycle. This is the high cycle and this is the half cycle. So this one wave we are calling that as a, you can say that as a one cycle. So the time period of this production of this one cycle, okay, we are calling that as a time period. Next term we are having that is a frequency. What is frequency? Frequency is basically denoted by the f. And what is frequency? Frequency, the definition of frequency is the number of cycle in 1 second. If there is a number of cycle in 1 second, we are calling that as a frequency. If we talk about the formula, so we are having f is equal to 1 upon t. Okay, if we talk about the SI unit of the frequency, that is hertz. What is hertz? Hertz is basically the unit of the frequency. You can write hertz, revolution per second, cycle per second. Okay, and if you talk about the hertz, so hertz is basically the unit of the frequency, and this is the audioable frequency, which means that we can hear. Okay, which is like round about 20 to 20,000 hertz. If the hertz is less than 20, so which we are calling that as a infrasonic. Okay, which we cannot hear, like the voice of insects. Okay, we cannot hear. If the audible frequency is more than 20, so we can hear that, and that is called the ultrasonic frequency. We can hear that, but if we talk about the infrasonic, we cannot hear that. Okay, so this was the fourth one, means the, you can say that the characteristics of the frequency. Okay, so this was about the characteristics. Okay, and if we talk about one more point, this is the frequency is basically inversely proportional to the time period. Okay, if the frequency is more, which means the time period is less. If the time period frequency is less, which means time period is more. Okay, and as well as the frequency is basically inversely proportional to the wavelength too. Okay, if we talk about the, you can say the relationship between the frequency wavelength. So as you guys all know, velocity is equal to distance upon time. Okay, and distance we are having that is the wavelength, we are calling that as the lambda. We are denoting wavelength as the lambda. Okay, and we are having the t. And if we talk about the t, so t 1 upon t we can write, and lambda. Okay, and if you guys, as you guys all know that 1 upon t is equal to the frequency, and we are having the lambda. So this is what, this is the relationship between the frequency and the wavelength. So to calculate the velocity of the frequency, we are using that formula. So this is the conversion, basically little bit confusion. So this was all about the wave types and characteristics.